Hi everyone and welcome to this lesson. Today we're going to learn about a linear function's inverse. We are going to learn how to determine it as well as how to draw it. Now we know from our previous lessons that a linear function should be in the form of fx equals mx plus c. And it is very important that when we want to determine a linear function's inverse, that the original function must be written in this form. Now, inverse of a linear function is also written in the form mx plus c, but to show that it's an inverse, we just simply write f to the power of negative 1x. Can you see the difference between how we write the inverse and the original function? Okay, please remember that. Now, what is an inverse of a function? An inverse of a function is the mirror image of the original function. Okay, now to show you this, we're going to start with this original function called fx equals minus 3x plus 3, and we know that it's a linear function, right? Now, we are quickly going to draw this linear function. Now, you know how to do it from our previous lessons. We want to find the y-intercept as well as the x-intercept. And to find the y-intercept, we make x is 0. So minus 3 times 0 is 0, and 0 plus 3 is 3. So our coordinates for our y-intercept is 0 and 3, and we can plot that point right here. There it is. Now we also want the x-intercept. To get the x-intercept, we make the y as 0. Then we take this constant to the other side. It becomes a negative 3. And minus 3 divided by minus 3 gives us a 1. So the x is a 1. So the x-intercept is a 1 and a 0. And we can plot that point right there. Here is our original function. We just connect the two dots and there is our line. Now what we want to do now is we want to go from our original function and we want to determine the inverse. Now this is quite easy. So the first thing that I'm going to do is I'm just going to write we want to determine the inverse, and look at how I write it just to show you that I'm going to calculate the inverse. Now we take this original function and in the place of fx I'm just going to write y to make it easier. So y is equal to minus 3x plus 3. This was our original function. Now pay careful attention. To get the inverse, we're simply going to swap the x and y around. So where we have an x, I'm going to write a y, and there it is. And where I had the y, I'm simply going to write an x. And it's really that simple. Okay, now that we have it in this form, we want to rewrite this equation so that it is again y equals something. Okay. So, or how can I say it in a different way? Y equals mx plus c. So the first thing that we're going to do is we're going to take this constant to the other side, and now we have x minus 3 equals minus 3y. And now we're going to have to divide both these terms with this coefficient, which is minus 3. And please remember, in front of this x we've got a positive 1, and 1 divided by minus 3 gives us a minus a third x, and then minus 3 divided by minus 3 gives us a positive 1, and that is equal to y. And that is now our new equation. Now let's just go and write it nice and neatly, and instead of y we're just going to write f to the power of negative 1x to show that it is the inverse, and that is now equal to minus a third x plus 1, and that is our inverse's equation. Now we want to draw this inverse, and you know that when we have a linear line we want to get the y-intercept and the x-intercept. To get the y-intercept, we're going to make this x a 0. So minus a third times 0 is 0 plus 1 is 1. So we have our y-intercept as 0 and 1, and let's go and plot that point right there. There we go. Now we also want the x-intercept. To get the x-intercept, we make our y a 0. Then we take this constant to the other side. It becomes a minus 1. And minus 1 divided by minus a third gives us 3. So our x-intercept is 3 and 0. Let's go plot that point. There it is. So here is our two points. Let's connect them. And there's our inverse drawn. Okay, nice and easy, right? Now, before we continue, I just quickly want to point out the following. Do you see that this was the coordinates for the y-intercept of our original function? Now, if we swap these two coordinates around, we simply get the x-intercept of our inverse. Okay? These coordinates here were the x-intercept of our original function. So if we swap these coordinates around, we get the y-intercept of our inverse function. Do you see? Okay, so basically an inverse is the mirror image of our original function, and it means that it's simply the x and y coordinates of our original function swapped around. Now let me show you graphically. Now here we have our inverse, and this was our original function. Now to know what is the mirror image, we introduce the line y equals x. Now this y equals x is simply going to be our folding line. So just like you are folding a piece of paper, we are going to fold the functions on this line. So basically, if I fold this original function, this part, over this y equals x, I'm going to end up with this mirror image of our inverse function. And if I take this part of our original function and I fold it onto this line, we're going to get this part of our inverse function. So basically, the inverse function is the mirror image of our original function. Got it? And when we swap the coordinates around, we simply get the coordinates of our inverse function. It's really that simple. So work through this video so that you understand the concept, and we'll see you again next time. Bye.